Now discussing the properties of matrices. The first property, which is addition and subtraction. How addition and subtraction works, like take a matrices of the format of A11, A12, A21, A22, and take another matrix B11, B22. Okay, now I want to add two matrices A plus B. Then how addition work? The addition of two matrices works when or if and only if the order of each matrices will be same. That means if it is M cross N matrix, this must should be M cross N matrix. Then we can apply this operation, addition or subtraction. The addition or subtraction will be component wise, like A plus B or A minus B, anything. So component wise means this type, like A11 addition or subtraction B1 with B11. Similarly A12 addition or subtraction with B12, A21 with B21, A22 with B22. This is the matrix operation, addition operation or subtraction operation. Okay, now the next property is matrix multiply by a scalar. Let a scalar A and a matrix A. Okay, then how it's look like? A is here present here, A11, A2, same example. Then this is A11, A12 with a A21 with a A22. This is a scalar multiple of a matrix, and if I explain this how it's work, like observe that, take an example, like A is a person, B is a person. Okay, we give you a statement that the height of A is 3 times of B. Then how you can write in mathematical way? A equal to 3 times B. That means the height of A is equal to 3 times B. Okay, 3B can be write in this way or not? Okay, so in the case of matrix A times small a times A, that means we can write A equal to A plus A plus A. This is A times. Okay, so if you add A in A times, then you can get this term. And how addition will be work in the previous case? So A multiply by a scalar with a matrix should be performed in this way. Okay, this is multiply by a scalar. Now we another properties, which is multiple by another matrix. That means the multiplication of two matrix. Okay, let take two matrix A, which is M cross N matrix, B another matrix which is N cross P matrix. Observe that why we take N here and why P, M. Okay, first observe that multiplication, how multiplication work. The multiplication of two matrix should be in this way, calculated in this way. This term will be multiplied with first term, that means first with first, 2 into 1, plus second term will be second term. Observe that the second term of row will be second term of column with multiply with second term of row. That means 1 cross 0. This is our first term. Similarly, for this row with this column, 2 into 0 plus 1 into 0. Okay. Similarly, for this row with this column, 0 into 1 plus 0 into 0. Okay, now the fourth term should be this 0 into 0 plus 0 into 0. So the final matrix comes from 2 into 1, 1 into 0, this is 0, it becomes 0, 2 with 0, this also 0, this also 0. Okay, so observe that how matrix multiplication works. The operation with each row of first matrix should be multiply, that means operate with the first column of second matrix. So one things, the number of element of each row should be equal to number of column element. Okay, so that's why we write here m cross n multiply when n cross p is present here. That means observe that number of row and column, number of element of row, that means this is n here. N, what is n? N is the number of column. Here number of column is 1, 2. Here number of column is 2. This should be equal to the number of element of, okay, observe that, number of row, that means here. Okay, you got my point or not? Yes. So that should be equal, the number of, here number of column should be equal to the number of row. Then we can multiply two matrices. Okay, so if you, they are not necessary that two matrices should be square. If a matrix is not square, then also we can multiply. Example here, 1 2 3 1 0 2. This is 2 row 3 column, 2 cross 3 matrix. Now we already told you that the number of column, first column, second column, third column, number of columns should be equal to the number of row here. So just take an example. So number of column is equal to number of row, but it is 3 cross 2 matrix. These are square matrix? Not a square matrix at all, but we can still multiply each other. The first thing is number of column of first matrix should be equal to the number of row. This is our main properties of matrix multiplications. Okay, the output should be 2 cross 2 matrix. Okay, you can check it by yourself. Now trace of a matrix. What is trace of a matrix? Let take an example. A trace of a matrix will be find when the matrix is square matrix. Okay, let's take an example. A12, A1, sorry, A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, what will be the trace matrix? Trace of a matrix. Trace of a matrix is equal to the sum of element of diagonal element. That means trace of A equal to A11, A22 plus A33. This is our trace of a matrix. That's all. Now let define transpose of a matrix. What is transpose of a matrix? Need not be a square matrix. Observe that it is a 3 row 4 column, that means 3 cross 4 matrix. What will be the transpose? I write the transpose of this matrix. First let's take a technique. What is the transpose? Write each column to each row. Again, make each column to each row. That means here is the first column. Okay, make it as a row, first row, A11, A21, A31. Second column make second row A1 2, A2 2, A3 2. Third column similarly A1 3, A2 3, A3 3. Fourth column make it A1 4, A2 4, A3 4. So the transpose of a matrix is easy process to calculate. So if I talk about the observes how transpose work, in the table format I already told you that example, like name format or roll number and marks. Okay, here is the some name, some roll number, some marks. I already told you that it's become a matrix. Observe that A is a matrix. Okay, now I want to find the transpose of that table or that matrix. How it's look like? That looks like name should be here, roll should be here, marks should be here. Okay, because of I told you that each row becomes each column. So each row should be becomes each column. Here it is the column. To make a name should be 1 by 1 here, roll number should be 1 by 1 here, mark should be 1 by 1 here. So I think you got my point or application of transpose of this. That's all. Thank you.